S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
In the previous lectures, we have studied about the transformers. Now, in this topic, we will study about how this is the working of induction motor. So, in the induction motor, there is basically rotating magnetic fields. So, that can be understood by the application of magnetic field in the induction motor. I will teach you about the rotating magnetic field in the induction motor. I am Narendra Kaur. Now, if you want to study this topic in detail, kindly refer this book by S. Chand Publishing. E-book link description is given in the description box. So, the first topic is our rotating magnetic field. Now, this topic is basically related to the induction motor. So, in the induction motor, firstly understand its parts. So, first part in the induction motor is known as static. Why this part is called static? Because this is stationary. So, that is why this part is called static. Second one, that is called core, or in the core of the induction motor there are 3 windings. And also why there are 3 windings? Because it is a 3-phase, or in short we can say that it is a 3-phase transformer. So that is why these are called induction motor with 3 windings. So what type of windings are used in this case? So first one is, here is the R, here is the R dash, R or R plus. This is the first winding over here. So that winding that can be represented separately over here. So second is the R over here. Now this winding R that can be shown like this. If this is the R and here is the R plus. What is meaning of R plus? From R, here the current is flowing in this direction. So this is the first winding over here. So in 3-phase diagram that we understood in the second unit, so there are the 3 colors, combination is used in the 3-phase. One is red, blue and yellow color. So same here, first winding is a red, R for red color over here. This is the first winding. Second winding is here yellow color, which is known as Y. Again this is Y plus, indicates the direction of flow of current from Y to Y plus. So that can, this type of winding that can be shown like this. So if this is Y, so here this will be the Y plus. So this is the direction of flow current in the Y winding. Third is the blue winding over here. So in the blue winding the current is flowing from B to B plus. So this is the third winding over here. This is the B and B plus. So means in case of induction motor, so there are the 3 windings. So these 3 windings can be shown like this. So there are 3 windings. One is the R, this is the direction of current. So in this case the current is flowing in this direction. Here the current is in this direction, then when the current is flowing in this direction, the field is induced according to Fleming's right hand rule. The field which is induced in this case, so the direction of field that is along this direction. So this is a BR, which is field induced in this case. Now in the second case there is a Y and second winding. In the second winding the current is flowing like this in this direction. So the direction of current will be, the generated field will be along this direction, and this is the By. And the third case, that is a B winding. So that is a, here is a B, this is a B plus. So again the current is flowing along this direction. So this is a direction of current in this case. So then according to Fleming's right hand rule, so that will be the direction of field in the blue winding. All these three components, they are connected to each other by an angle of 120 degree. Means when we plot separately this resultant field for these three, so if this is a value of BR, this is a value of BB, then that is a BY. Means all these three, they are at an angle 120 degree to each other. So this is all about the principle of or the working of this induction motor or the rotating magnetic field. So clearly in case of this induction motor, so if this is a static or stator of the induction motor, and this is a core of the induction motor. So there are three windings in the motor present. These are the three windings. So these are the three windings present in the core of the induction motor. Now when the current starts flowing in these three windings, due to flow of current in these three windings, the magnetic field is developed. You can say that the induced field is developed in the three winding, and due to induced field in these three windings, due to induced field, the net field that can be also calculated. Now according to mathematical relation, when it is used, the field values that can be written like this. So these can be represented over here. So this is the resultant field due to R winding, first winding. This is due to the blue winding, and that is due to the yellow winding. And the angle between these three is 120 degree over here. Here the angle between these is so this is a 120 over here. Again this angle is 120 and this angle is 120. And the resultant of these three, that can be represented as BT. What is BT over here? BT is the total magnetic field which is developed in the three-phase induction motor due to three rotating field. Now these three fields are rotating over here. So due to three rotating field, these rotating fields, the magnetic field is developed in the induction motor. Here this area is not free space. So in this area, when the field is rotating in the internal core of the induction motor, due to this, here the EMF is induced. From that induced EMF, in this rotor winding, from this induced EMF we will get, if this is the input power is given over here, and here we will get the output power. So that can be calculated. So this is all about the working of induction motor. Now next is the total field that can be calculated. Now what we want to calculate, how the flux can be represented, because we know that flux that can be represented as flux is equals to phi into A. Flux that can be written like this, flux is equals to B into A. What is B here? That is a magnetic field which is flowing in the given area. What is A? That is area. So the rate of change of flux that can be written as now in the first part the field is changing with the time, while in the second part area is changing with the time. So we know that in case of transformer area is fixed. Why area is fixed? Because every part is in the static condition. No part is moving. No part is moving. So the first part is represented. How we write this? Firstly differentiate here phi with respect to time t. The product rule is applied over here. So first is as it is, then dB by dt plus, then second as it is dA by dt. Here the product rule is applied over here. So the first component here that represented the rate of change of flux in case of transformer. So first part here represented the transformer part. So in which case in the transformer part everything is in the static condition. No part is moving. While in the second part here the area goes on changing. While in the induction motor, when the three windings, the magnetic field is moved in the three windings, they are constantly moving. The three windings are in motion. So that means the area goes on changing. So the second part that is related to the induction motor. Means in the induction motor, as soon as the area goes on changing due to presence of magnetic field, the flux is induced. Here the flux is induced in the induction motor. So in this case we have studied about how the field goes on changing. So in this case we studied about in this part, firstly in the first part we have studied about the working of induction motor, and also we have studied how the magnetic field is rotating and how it affects the rate of change of magnetic field, how it affects the change in flux. Now in the upcoming part, second part, we will study about how this magnetic field is related to flux and calculated some its mathematical relations. Now if you want to study this topic in detail, kindly refer this book by S. Chand Publishing. E-book link description is given in the description box. If you like this video, please kindly like, subscribe and share this video, and also press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.